in this lesson, we are going to talk about combining like terms. And with combining like terms, what we're going to do is we're going to take the expressions that we've been making with distributive property and everything else that we've been doing, and we're going to make them as small as we possibly can. We're going to simplify them by combining like terms, and we're going to talk about what like terms are. So what are like terms? So like terms have two characteristics. The first characteristic are that they have the same variable and the same exponent, and I'm going to show you what that looks like. The second characteristic is that the coefficients can be different, and remember that the coefficient is that number that's in front of the variable. So let's talk about what some examples might look like here. So some examples of like terms would be 5x squared and 7x squared. The variables are the same, x, and the exponents are the same, 2 and 2. But the coefficients can be different, 5 and 7. That's okay. Another example would be y to the third power and 6y to the third power. The variables are the same, y, and the exponents are the same, third power and third power. But it's okay for the coefficients to be different. So here's a 6, and remember there's an invisible 1 here. Another example would be 22w to the 8th power and 4w to the 8th power. The variables are the same, w and w, and the exponents are the same, 8th power and 8th power, but the coefficients can be different. Now the coefficients can also be the same, so that's important to know. If this was a 4 and this was a 4, that's okay as well. Let's talk about some things that are not examples. So if I had 5x, actually, and I want to do this in red here. So if I had 5x squared and I had 7x to the third, this would not be like terms, and the reason why is because the exponents are different. The exponents cannot be different. They have to be the same. Another non-example would be 4y to the 5th and 9y to the 7th. Again, our exponents are different here, and we're not allowed to have different exponents. And another non-example would be 11w to the second power and 4x to the second power. Now in this case our exponents are the same, but our variables are different, and we're not allowed to have different variables. So let's do a quick check on that real quick. Let's determine if these are like or unlike. So here I have 4x and negative 10x. So I have my same variable and they have an invisible exponent of 1. So these are like terms. Let's check the next one, 6p and 5p to the 4th power. So this is a p to the 1 power and this is p to the 4th power. They have the same variable, but their exponents are different, and that's not allowed. So these are unlike terms. The next one, negative 12y to the 3rd power and negative 12x to the 3rd power. They have the same exponent, which is good, but their variables are different, which is not good. They need to have the same variable, so these are also unlike terms. Here we have 15x to the 2nd power and 17x to the 2nd power. The variables are the same, x, and the exponents are the same, 2 and 2. So these are like terms. I know this one looks complicated down here, but it's really not, I promise. So we have 13, w to the 4th, x to the 2nd, y to the 7th, 2, w to the 4th, x to the 3rd, y to the 7th. We need to check, do all of the variables match and do all of the exponents match? W to the 4th, w to the 4th. We're good so far. X to the 2nd, x to the 3rd. We have a problem. These exponents right here are different, so they are not the same, so these are unlike terms. When they're all smushed together like this, that means that they're all together as one term, and so they all need to match. Alright, so before we jump into actually combining, let's take a minute to do a quick review. we need to list the terms, the like terms, the variables, the coefficients, and the constants. Remember, when we do terms, it's easy to box them off, and when they have a minus sign in front of it, we need to take the sign with it. And so I'm going to go ahead and box off my terms real quick. So my terms are 6x, negative 2y, x, and negative 5. Now, what are my like terms? So what are my terms that could go together? Well, I have a 6x and I have an x. So I'm going to put those over here together. What are my variables? Well, I have an x and I also have a y. What are my coefficients? The numbers in front of the variables. So here I have a 6. Here I have a negative 2. And then here's an invisible 1. And then last but not least, what are my constants? And I only have one, which is a negative 5. And constants are the numbers that are by themselves. Alright, one last quick review. Let's name our terms, and so I'm going to go ahead and box them off so that they're easier to see. And remember, when they have a minus sign in front of it, we need to take the minus sign with it. So our terms are 13m, 4, negative 6m, and 10. What are our like terms? Well, we have 13m and negative 6m. And then I'm going to draw a line here because we also have another set of like terms, 4 and 10. They don't have any variables and they don't have any exponents, but they're two numbers that can combine. Alright, what are our variables? We only have one, which is m. What are our coefficients? We have 13 and we have negative 6. And then what are our constants? We have 4 and we have positive 10. Alright, now let's talk about how we combine these. So remember, we need to have the same variable and the same exponent in order to combine them. So here we have 3y plus 4y. So we have y to the first power and y to the first power. Remember that if there's no exponent, there's an invisible first power there. Once you establish that they are like terms, you know that you can just take the coefficients, which is 3 and 4, and follow the operation, which in this case is addition. So 3 plus 4 is 7, and then you're going to keep the variable and the exponent. So it's going to be 7y is your answer. Let's try this one. So I have 14m to the first power minus 8m to the first power. So it's m to the first power, m to the first power. These are like terms, so I can combine them. So I have 14 as my coefficient, and then I have minus 8 right here. Remember, I always take the sign in front. So 14 minus 8 is going to be 6, and then I keep the variable with the exponent. So 6m is my answer. They're going to get a little harder here, okay? So here I have 17k to the first power, k to the first power, and 2k to the first power. We have to be very, very careful about our signs here, okay? So I have 7k minus k plus 2k. Now, what's the invisible number that goes here? 1. So what's 7k minus 1k? 6k. And then I'm going to rewrite the rest of the problem. We have to follow order of operations here. I see all addition and subtraction, so I need to go in order from left to right. So 6k plus 2k is going to be 8k. And that's my final answer. Alright, over here I have 14a minus 6a plus 2a plus 11a. Now these are all a to the first power, so they're all the same, so I can combine them all. But remember, I need to follow order of operations and go in order from left to right. So I have 14a minus 6a plus 2a plus 11a. So I need to take them in order. So 14 minus 6 is 8a. And then I'm going to rewrite the problem. Plus 2a plus 11a. So then I have 8a plus 2a That's 10a plus 11a. So 10a plus 11a is 21a. And it is going to get trickier than this when we add exponents in. Alright, so let's try multiple variables here. So here we have 4h plus 6h plus 12g minus 2g. So when we have different variables, a really good tip is to use a highlighter to highlight the different variables. So here I have a 4h plus a 6h, but then I'm going to switch colors and do a 12g minus a 2g. Because these could be all mixed up in different order, which we'll get to with a lot of examples in class and even later on in the lesson. So 4h plus 6h, that's going to be 10h, okay? Then do the next one. We have 12g minus 2g, that's 10g, okay? Now, how do you put these in order for your answer? You have to go in alphabetical order. What comes first, H or G? G comes first. So your answer is 10G plus 10H. How do you know if it's plus or minus in the middle? Well, is this positive or negative? Positive. Positive or negative? Positive. If one of them was negative, then it would be a negative in the middle, which is a minus sign. We'll get there though. Alright, so here I have 5k plus 20a minus k minus 6a. So I'm going to highlight my k's in green, and remember you take the sign in the front, and I'm going to highlight my a's in blue. And you'll see it really helps you figure out the difference. So I'm going to do my k's first. So I have 5k, and then look here, minus, and what's the invisible number there? Minus 1k. What's 5k minus 1k? 4k. And then here I have 20a minus 6a. What's 20a minus 6a? 14a. Now I need to put them together for my answer. Alphabetical order, what comes first? K or A? A comes first. So 14a, and then this guy is positive, so plus 4k. Alright, next one. So here we have some with higher exponents, okay? So I have 5d to the third power plus 5d to the third power. Now, they're both d to the third power, so they're the exact same thing. So I can combine them. 5 plus 5, 10d to the third power. And that is my final answer. Alright, 8x to the second power plus 9m minus 3x to the second power. Use your highlighter so that you can highlight the different terms. So I have 8x to the second power, and then here I have minus 3x to the second power. And then I have a plus 9m here by himself. So solve each part individually. So here I have 8x to the second power minus, because you have that minus there, minus 3x to the second power. So again, you have your like terms, so just use your coefficient. 8 minus 3 is 5x to the second power. And this 9m, he can't combine with anybody. He's sort of by himself. So he's just 9m. Now in this case, we're going to add another layer onto the ordering. So I told you alphabetical order, but there's an exception. So in this case, if I told you alphabetical order, the 9m would go first. The exception, though, is if somebody has a bigger exponent than you. So bigger exponents go first and then alphabetical order. So in this case, this guy has a bigger exponent than the m because he only has an exponent of 1. So 5x to the second power, and the m is a positive, so it's going to be plus 9m. Alright, let's get our highlighters out here. So 9r plus 2r to the fourth minus 7r. So here I have a 9r, and here I have a minus 7r. And then here I have a plus 2r to the fourth. So let me start to solve. I have 9r minus 7r equals 2r. And then I have this positive 2r to the 4th power who's all by himself. So I need to just put them in order for my final answer. Remember, he has the bigger power, so he goes first. 2r to the 4th power, he's positive, so I put a plus 2r. Now, a lot of people are tempted to combine these, but they cannot combine. Yes, they have the same variable, but they do not have the same exponent, so do not combine them. Alright, 3n minus 2n plus 5 minus n. So let's go ahead and highlight. We have a 3n, we have a minus 2n, we have a minus n, and then we have a 5 who's all by himself. So 3n minus 2n equals 1n. Okay, so we took care of these two guys. 1n, and then here I have minus 1n. Well, what's 1n minus 1n? 0. Nothing. So there's nothing left there. So my answer is 5, because all I have left is my 5 right there. Alright, you try these 3 on your own. Make sure you use your highlighters. Alright, if you're not done, go ahead and hit pause, and if you are done, let's go over it. So for the first one, you need to take 13p to the third minus 9p to the third, and you get 4p to the third. Then you have 12 minus 1 is 11. So your final answer is 4p to the third plus 11, and it's plus because the 11 is positive. For the next one, you have m plus 9m, and remember there's an invisible number 1 there, so it's 1m plus 9m is 10m. But then you have 3 minus 3, which is 0, so your answer is just 10m. For the last one, you have 2r to the 5th power plus 2r to the 5th power, which is 4r to the 5th power. And then you have 10 minus 7, which is 3. So 4r to the 5th power plus 3. Alright, that is the end of this lesson. We're going to spend a couple days on this in class, so we will have lots of time to practice.